Okay, so you are here to learn about condensing logarithms. So the word condense isn't a term that's always used in regarding this. You may see things like combining logarithms or rewriting them as a single logarithm. There's different words you can use. I use the word condense because you're normally taking something that's really long and you're making it a lot shorter. So that's just the terminology that I use. So just a brief review, if you haven't gone through logarithm stuff yet, then this will not be reviewed, but it is covered this week. So we're learning about logarithms, and they are the inverse of an exponential function. And we abbreviate it with a log. And if there is no subscript after the G, so there's no number underneath there, it's assumed to be a base 10 log, where your base is 10. That would be what you'd be 10 to some power if you were to rewrite it. And then ln stands for natural log, and that has base e. And we use that often enough that we have a different symbol for that. So on your calculator, you'll see ln and you'll see log, and those are the base 10 and the base e logarithms. So there are 4 basic properties that you can use to simplify logarithms. The log of anything, or the log of 1, any base, is equal to 0. And if whatever you're taking the log of and the base match, that gives you 1, because they basically kind of cancel out. And if there's an exponent on that thing, then your answer is the exponent, because the logarithm is like telling you what is the exponent. So any number to the 0 power gives you 1. That's why the log of 1 is equal to 0. B to the first, that exponent is 1. That's why the log is equal to 1. And so then taking the logarithm of the same base to the exponent x, you get an answer of x. And it also works the other way. You can have an exponent and then the logarithm in the exponent, and those will cancel out and still result in x. So these are used for solving logarithms. They're used for simplifying. What we're going to be doing uses different properties. And these other properties they allow us to kind of combine logarithms together, or separate them out as needed. So we've got 3 properties here that we're kind of adding. And B, the base has to be positive. Whatever you're taking the logarithm of has to be positive. So you can't take logs of negative numbers. And then your exponent, if you have an exponent on something, that actually can be positive or negative. That doesn't have to be a positive number, but pretty much everything else has to be positive. So we have what is called the product property. And so if you have things that are multiplied together inside the logarithm, you can rewrite those as 2 separate logarithms. So you can kind of separate it out. And it makes sense when you think about our rules of exponents. So the rules of exponents say that if you're multiplying things to the same exponent, you add them together, as long as the base is the same. So since logarithms are basically giving you the exponent, it makes sense that if you have a logarithm of things multiplied together, that then you add them, because it's just like what you would do with exponents. We have the quotient property, which is also very similar to exponents, where if you have division going on inside a logarithm, you can rewrite that as subtraction. And that stems from the fact that if you are dividing things with exponents, the exponents subtract. So it's the same rule where you have something with division, and in this case, we can rewrite it as subtraction. And then we have the power property, which it kind of has an analog, I guess, as far as the exponents. It's if you are taking the log of something and it has an exponent, the exponent can be rewritten to be in front, basically multiplied by the log. So this is sort of like if you are multiplying It's that exponent, because the logarithm gives you the exponent and you have an exponent on top of something that is an exponent. It's equivalent to if you had two exponents like on top of each other, like I have here, a to the m to the n. And when you simplify that or rewrite it, you multiply those together. So that's why you're allowed to multiply your exponent of p times the logarithm, because that logarithm is basically like giving you an exponent. But it just looks very different when it's written in logarithm form versus exponent form. So these are the properties for simplifying logarithms. These are helpful. Well, first, it's helpful to understand logarithms if you have to deal with really large numbers. Sometimes it makes sense to take the logarithm of numbers so you have smaller numbers to deal with. Sometimes there's different types of graphs that have different grids where the grid is base 10 log. And so what you're graphing is on a different scale, essentially. If you have to go on to calculus, a lot of these properties are helpful to try to make things easier to do when you're taking derivatives and integrals, as you want to use these properties to kind of rewrite it in a way that will make it easier to work with. It's good practice for just kind of practicing rules and how things are related. And back before calculators existed, these are the rules that people would have to do in order to find a logarithm of a number. So logarithms were invented, I believe, in the 1700s by Napier. I don't remember his first name, but he's French. He basically invented the logarithm, and no calculators back then. So what they would do when they actually started working with these things is that they would just literally have a book of the values of various logarithms for different bases. And you would have to rewrite your logarithms. If you had a bigger number, you would have to split it up so that it's in smaller numbers that you can find in this book. So you can actually calculate out your logarithms. So these were very important back before calculators. We don't have to do that anymore, but they're still handy in various aspects. So what we're going to be doing is kind of reversing all of these rules. So the left side of all these rules were kind of splitting things apart, kind of making it bigger, so to speak, on the right side. We're going to be taking things that look like they're on the right side and we're going to put them back on the left side. So we're taking what might be written with a plus or a minus, and we're going to condense it, kind of combine it into a single logarithm. So we're going to be going from the right to the left here. So there's lots of directions you might see: condense the logarithm, rewrite the logarithm. Here it says use the properties of logarithms to write the logarithmic expression as a single logarithm. So you want to look for those things where they're asking you to do a single logarithm, because that tells you that you're going through this process. And then you simplify as much as possible. Like if there's numbers you can divide, you divide those out, that sort of thing. So I've got two examples here. We'll start with the one on the left. We've got log 5 plus log p. So the rules for using these properties is that the base has to be the same. So they both have to match. So these are log 10. We don't have the 10 underneath there, but we assume it's log 10. So these are both log 10. So that means we're allowed to combine these. If one was log 2 and the other one was log 10, you can't do that. So they have to be the same base in order to combine. Much like when you have exponents here, in order to multiply those things together and add the exponents, they have to have the same base. So same applies with your logarithms. So we have something that's added together. We're going to write it as multiplication. That's going to be using the product property, where we're taking two things that are added and we are recombining them into one thing where they're basically multiplied together. So just writing down the product property, what this means is that if we have the log base 10 of 5 and log base 10 of p, this is equal to the log base 10 of 5 times p. So we can basically combine those together as multiplication. And then you would try to simplify further if possible. 5 times p doesn't mean anything. We've got a variable, so we can't actually find a number for this. It's just a matter of rewriting it in a way where it's shorter. So on the right, we have log base 6 of 144 minus log base 6 of 4. So here we have things that are just numbers. And so we want to, again, use a property in order to combine this into a single logarithm. So we're going to be using the quotient property here because we have things that are subtracted. And so we're going to go from the right to the left and write it as a fraction. It's always the first thing over the second thing. So whatever's before the subtraction sign is always on top. So this is called the quotient property. And so we have log base 6 of 144 minus log base 6 of 4. And we can combine this, still log base 6, but it's 144 over 4. So we're taking log of 144, so that goes on top, and that was before the subtraction sign. And then after the subtraction sign, we have the log of 4, so that goes in the bottom. Now this we can simplify because we can do 144 divided by 4. I'm pretty sure that comes out to a whole number. Yes. So that gives us log base 6 of 36. So we can simplify that 144 to get us a value of 36. So a problem like this just says use the properties of the logarithm to write it as a single logarithm. So we have done what it was asked for. We have written it as a single logarithm and we simplified the 144 over 4. Now, this problem doesn't ask for more, but we can go further in this case. We can actually evaluate this. So the word evaluate means find what this is equal to, like whatever the actual number value is of this. So this problem doesn't ask for that, but we could do that. So if we were to evaluate log base 6 of 36, we can use these rules, these properties. So first, now this is actually something that you can't do on a calculator because our calculators don't have base 6. So this is one reason why you do actually have to know these rules, is if you get something like this and you don't have a calculator that can do other than 10 or the natural log. Like my calculator doesn't have those options. So I would not be able to put this in my calculator. But what we do is we first rewrite 36 as its exponent form. So that is log base 6 of 6 squared, because 36 is equal to 6 squared. Now, one of the properties that we haven't used yet here is the power property, where if you have an exponent, it can go down in front. So what that means is this exponent of 2 can basically be written in front of our log. And so, whoops, not 2, 6, 2 times a log base 6 of 6. And then we have, and we could have used multiple properties here. So we could have actually used this property right here because we were in this form, but I wanted to demonstrate using the product property. So we're going to use this property where if you have your base and then what you're taking the log of are the same thing, it equals 1. So this log base 6 to 6 is equal to 1. So we get 2 times 1, and this actually comes out to the number 2. So I'm doing this for multiple reasons. One, to kind of go over the directions, because one thing that often mistakes are made or not following the directions. So the directions that we had here says use the properties of logarithms to write as a single logarithm and then simplify. That's what I have boxed. We can go further here, but we don't unless it has the phrase evaluate, because then it's saying I am looking for what this actual number is that we are equal to. So you really want to pay attention to those words, simplify versus evaluate, so that you make sure that you are giving what it asks you to, because it's possible to go too far and still have done correct work, but it wasn't what was asked for. Are there questions on either of the two, the one that I did with the product property, the quotient property, or the evaluating part? Okay. So, and this actually, what we did with the quotient property and evaluating, that's basically what people would have to do without a calculator. Let's go through all those kind of steps. Okay, so now we're going to kind of ramp it up. So again, I've got 2 examples here, and we're going to be using more than one property essentially to simplify these, or to rewrite them as a single logarithm. And these essentially can't really be simplified further, so I just left that off of the directions. So on the left, we've got 2 times log base 2 of x plus 4 times log base 2 of y. So these are the same base, so we can use our rules to combine these. Now the question is, which rules do you use in what order? Because the order that you use your rules matters. So let's go back to the 3 rules we're focusing on. We've got the product property, the quotient property, and the power property. So you're going in the order of operations. So order of operations says you deal with exponents before you do any multiplication or division, and before you do any adding and subtracting. So what this means is that you do your power property stuff first, and then you do your product or quotient property, and that depends on going left to right, because those involve adding and subtracting, and multiplication and division, those go left to right. So you're always doing your power property first, and then the product or the quotient property based on order left to right. So label that as 1, and then the power and the quotient are basically step 2. So if you try to do it in a different order, you could make it work, but you're more likely to make errors by multiplying things that aren't supposed to be multiplied, putting exponents that are supposed to be, as a number multiplied instead of as an exponent, that sort of thing. So what this means is that we first take the coefficients and we make them exponents. That's what this power property is doing. So we did the opposite when I used it to evaluate. We took the exponent and we put it down in front. The power property, if we go in the other direction, it makes whatever's in front become the exponent. So it goes back up in the exponent. So when you're working from right to left, you're putting it back up there. So we're going to rewrite this as log base 2 of x squared plus log base 2 of y to the 4th. So those numbers in front, those coefficients become the exponents. And so that is using the power property. Then once you've done that, now if you've got addition, you use the product property where you combine them and multiply them together. If you've got subtraction, then you use the quotient property. So we are going to be using the product property. And we combine these into a single logarithm by multiplying them. So that's going to be x squared times y squared, or y to the fourth, sorry. And I always make sure that I put these in parentheses so that it's clear that that whole thing is within your logarithm. And I would encourage you to do that as well, especially when you're entering your answers into Alex, is to make sure that you've got everything where it should belong, especially when you're entering logarithms. When you click the button in Alex as a box for what goes in the logarithm. So you need to make sure that everything you're writing is in there and not accidentally outside of the box. So I use parentheses to make sure that I'm in there where I should be. So once you've combined it, there's nothing more we can do here because we can't simplify x squared y to the fourth. There's nothing we can do with that. So not bad. It's just two steps, basically. Make your coefficients in front become exponents, and then you combine it into a multiplication, and then you're done. Now you have a single logarithm here. And that base, it doesn't matter what that number is. You just keep writing it with your log. You don't have to multiply it or add or do anything like that. There are questions? Okay. So the one on the right here, now we've got multiple subtractions going on here. We've got 4 log base 8 of m minus 3 log base 8 of n minus 2 log base 8 of p. So we've got multiple subtractions, and so we need to do these from left to right. If you try to change the order, you can do it correctly, but you tend to make mistakes unless you really know your sign rules very well. And we know that that's where people struggle. So we are going to go left to right, and we're going to do it step by step. So the first step is to use that power property. And we're going to put all of those coefficients up as exponents. And when you do this, just ignore the minus signs because those are going to be used for we're going to use our quotient property to combine them with division. So you can ignore the minus signs and just put the numbers up there. So we're going to have log base 8 of m to the fourth minus log base 8 n cubed minus log base 8 p squared. And then we're going to work from left to right. So we're going to use the quotient property on the first two things that we're seeing here. And so that quotient property is when you've got subtraction, you make it a fraction. And so we're going to combine that into a single logarithm. So we're going to have log base 8 of m to the fourth over n cubed, because it's the first thing divided by the second thing, much like it's first minus the second. And then I still have this log base 8 of p squared after that. So we needed to combine the first two things. And then we have to apply the quotient property again. So we have a fraction and we are dividing it by another fraction here. So you basically end up with a fraction inside of a fraction into a fraction. The nice thing here is that if you haven't figured out when you're working with fractions, is that every time you divide a fraction by another fraction or by something else, that always just ends up in the denominator. So what this means is this minus the minus log 8 p squared, the p squared is going to be in the denominator because the minus, it's after the minus sign, it's just going to be in the bottom along with the n cubed. So this is going to give us log base 8 of m to the fourth, pardon, over n cubed p squared. So each kind of minus that you have here, thank you guys. Yeah, I could feel it coming and I'm like, I don't know if I can stop that sneeze. So whatever is after that minus sign goes in the denominator essentially. So even if you have multiple minus signs, you just kind of go from left to right and then it goes in the denominator. So we end up with this single logarithm. We've got m to the fourth over n cubed p squared. And so that cannot be simplified further. We can't like combine any of those exponents or anything like that. So that is your final answer. And this kind of rule where it works with the plus sign as well. So if you have logs that are added on, everything that's after the plus that has a plus is going to go on top. So we could have done this in like 2 steps, knowing that I had this minus log base 8 n cubed and minus log base 8 of n p squared. I could have put those together in the denominator all in 1 step because they were both minus. But I don't like to do that just because it could get confusing. I like to do it one at a time so I can really see what's going on here. Any questions? Okay. So now we've got an even longer one. You know how I roll. We make things more difficult as we go. So we've got lots of things going on here. I've got this 2, and then we've got brackets, which is just a way to group this together. Then we've got log of p minus 4 minus log p minus 1 minus log p plus 4. So we're still going to kind of work reversing going through the order of operations. So we would be doing the power property, but the power property works when you've got a number right in front of the log. We've got a number in front of a bracket. So we actually have to distribute that 2 through before we can do our power property. So that 2 is going to get multiplied by each one of these logs. So we better move all the way to the left here. So I'll have 2 times log of p minus 4 minus 2 times log of p minus 1, and then minus 2 times log of p plus 4. So you just, any number that's outside, if you've got brackets or parentheses, you want to distribute through the logs before you start doing your power property, because you want to make sure that you put it in the right spots. Because if you try to do the power property with just that 2, it's very easy to only put it on one of them and not all 3. So distribute it first. Then we're going to use that power property. So all of these are going to become exponents. And so I like to draw, with arrows, so I remember that's kind of what's going on here. So we get log of p minus 4 squared minus log of p minus 1 squared minus log of p plus 4 squared. So all of them had the same coefficient, so they're all just becoming exponents of 2. And then we're going to work from left to right and use our quotient rule. So the minus means the quotient rule, you're going to make it a fraction. So we're going to combine this into a log of, and I need to have lots of parentheses here to make sure that I have it correct, p minus 4 squared over p minus 1 squared. And all of that is inside that logarithm. So I've got it looks kind of messy with lots of parentheses. And you don't really need those outside parentheses other than just to make sure that, like, if you had to type it somewhere that you have it correct. And then I've got log of p plus 4 squared. And then once again, we have a minus here. So to combine it all together, that's going to be another division. So we're going to do the p plus 4 squared. The thing that's after the minus sign is going to go in the denominator when we combine these. So we will end up with log of p minus 4 squared over p minus 1 squared p plus 4 squared. And if possible, you would try to like simplify and cancel things out, but nothing really cancels out. There's no like terms. We can't simplify that fraction. You do not want to try to multiply that out. That's going to be really gross. So you just leave it like that. You know, don't do more work than you have to. Don't do more things where you're more likely to make mistakes. It's like, if you can just leave it like that, leave it. Any questions? Okay. So again, we are kind of throwing in some more things here. So I don't know if this one looks easier or harder than the other one, but we've got, I usually think if I throw a fraction in there, it usually looks harder to people. So we've got this 1/3 log base 4p plus log base 4 of q squared minus 16, and then minus log base 4 of q minus 4. So we don't have any like distributing that we need to do here. So we can go straight to our power property, where we're going to take this 1/3 and that is going to become the exponent on the p. And that's the only coefficient we have. So that's the only thing that's going to get an exponent. The rest of these don't have that to worry about. So we're going to have log base 4 of p to the 1/3 power plus log base 4 of q squared minus 16, and then minus log base 4 of q minus 4. So now we're going to work from left to right. So the first thing that we hit when we move to left to right is the plus. So that's going to be combining these as multiplication. So we're going to be multiplying inside the log p to the 1/3 times this q squared minus 16 thing. And so this is the product property that we're using. Again, we're going to have lots of parentheses here, and the parentheses are really important to make sure that you're saying that the q squared minus 16 is inside the logarithm, not multiplied by the logarithm. Because if I just do different colors here, if I didn't have the parentheses, somebody could interpret it to look like this, which is a very different meaning, because that means the q squared minus 16 is outside the logarithm, not inside. So putting parentheses when you've got a whole bunch of things multiplied together is actually kind of important to make sure that it's read correctly. And then I've got this minus log base 4 of q minus 4. So now we're going to take care of the minus sign by combining it, and that's going to give us a fraction. And the q minus 4 is going to end up in the denominator. So we've got log base 4, and I'm going to have this big parenthesis for my fraction, p to the 1/3 times q squared minus 16, over q minus 4. Now the directions in here don't say to simplify, which is an oversight on my part. I really should have written simplify, so I'm gonna put that right here, because we can actually simplify this, because the q squared minus 16 can be factored, and then we can actually cancel out the q minus 4. So it's actually to our benefit to try to simplify this. And so this would be, we have this log base 4, we have p to the 1/3, q squared minus 16 is a difference of squares, and that factors to q plus 4, q minus 4. And you want to simplify if you can and notice those sort of things, because then that can get rid of fractions if you have fractions inside of logarithms. So that actually cancels out one of our q minus 4s, and we no longer have a fraction in the logarithm, which is great. So this would give us log base 4 of p to the 1/3 times q plus 4. So it actually looks much simpler. Now, the other thing that you do need to know, especially when you're working with Alex, is that you're going to see some of these with radicals. And the radical is a 1 over something exponent. So we learned that like a square root is equal to the 1/2 exponent. 1/3 is a cubed root. So when you're working with these things, if you see radicals, you kind of combine them into their, so not in this, so if we're taking a single logarithm and we're trying to expand it out, which is the opposite of what we're currently doing, you usually take any radicals, turn it into its exponent form, and then you can use the power property to remove all of your exponents on your logarithm stuff. So that means when we're reversing, we want to reverse that and put it back into its radical form. So the p to the 1/3, that is the cubed root of p. So the final way that we'd want to write our answer here would be as the log base 4 of the cubed root of p times q plus 4. And that q plus 4 is not inside the cubed root, it's separate. So it actually might be easier if we put that in front so it doesn't get confusing. But we can write q plus 4 with parentheses and then the cubed root of p. And so when you are trying to combine these as a single logarithm or condensing them, you know, if you see something that you can simplify by factoring, once you have it in a single logarithm, you do that. And then if you have any exponents that are fractional exponents, you put them back into the radical form, because we generally don't leave our final answers in that form. It's like a transitionary state in order to do other stuff with. Other questions? Okay, so I've got one more. Again, we have this fraction exponent of 1/3, so that's going to tell us that we are going to, you know, be writing something as a cubed root here. We have the natural log in this case, so that's ln. It's not the that's not the number 1 and then an n. It's the letter L, a lowercase l. I usually write my ln in cursive so that it doesn't look like the number 1. I've seen people write the wrong symbols there. And it's an ln because it actually is the French. So I said that like logs come from Napier. He's French. So we call it the natural logarithm, but it actually comes from, I guess in French, it's said the other way around. It's logarithm natural or something like that. So in French, ln makes sense because that's the order that they say it in French. So that's where the symbol comes from. But we have it, you know, we say natural log, so we say it in the other order. So it doesn't really make sense for us, but it actually made sense at the time that it was named. so that's where the ln comes from versus nl. It's like literally the abbreviation. So we've got this 1/3, and then we've got these brackets. So that tells us we're going to have to distribute the 1/3 through the parentheses before we do anything else. So I need to multiply. I've already got an exponent of 12 there. So we need to actually multiply those together and simplify before we make an exponent. And so that 1/3 is also going to be attached to the natural log of x there, and then the minus natural log of x cubed. So 1/3 times 12 is the same as 1/3 times 12 over 1. So that's 12 over 3, which is equal to 4. So this is going to give us 4 times the natural log of x minus 5 plus 1/3 times the natural log of x minus 1/3 times the natural log of x cubed. So I've just distributed that 1/3 through our brackets. And then we want to use the power rule. So all of those coefficients are now going to become exponents. And so the 4 will become an exponent on the x minus 5. 1/3 will be an exponent on the x. And then if you're wondering what happens here, it becomes another exponent on the x cubed. So we're going to have two exponents, kind of an exponent on top of an exponent that you're going to simplify using our rules of exponents. So we're going to get the natural log of x minus 5 to the 4th plus the natural log of x to the 1/3 minus the natural log of x cubed to the 1/3. And before we go any further, it makes sense to actually simplify that natural log of x cubed to the 1/3. So our rules of exponents say that you multiply your exponents together. So when we multiply 3 times 1/3, that is equal to 1. Those cancel out. So we can rewrite this. We have natural log of x minus 5 to the 4th plus the natural log of x to the 1/3 minus natural log of x, because that 1/3 on that exponent of 3 are going to cancel out. So it's 3 times 1/3, that's 3 over 1. You have 3 over 3, which is equal to 1. So it just cancels it. So sometimes you need to do some simplifying along the way when you have things that you can multiply. So now that we've got that done, now we want to move left to right and start combining these into a single logarithm. And so that will bring us to the product property first, because we have a plus here. So we're going to have the natural log of x minus 5 to the 4th times x to the 1/3. And those are then all in a big set of parentheses because that whole thing is in the natural log. And then minus the natural log of x. Now we've got this minus here. So now we want to do subtraction, which is creating a fraction out of this. And so the natural log of x, that x is going to become in the denominator. So we're going to have the natural log of x minus 5 to the 4th is x to the 1/3 over x. So we've got this natural log, and then we've got several things going on here. Now, we do want to try to simplify whenever possible. We've got an x on top, the x to the 1/3, and then we have an x in the denominator. So normally when we've been simplifying things with exponents, we had whole number fractions. You know, we didn't deal with a 1/3 and an x, which has an exponent of 1, and do that kind of subtraction. So what we are going to do, because whenever we deal with fractional exponents, we basically put it in its radical form. So that is what we're going to do. And I'm going to kind of move to a new slide here because I'm definitely going to need more room than what I've allotted myself here. So we've got our natural log, and we've got the x minus 5 to the 4th. And generally, so we've got multiple things that we can do here. Because our cubed root, because that 1/3 is a cubed root, we can just turn that 1/3 exponent into a cubed root and then kind of leave it at that, because now they're not basically the same. You know, they don't look like you can simplify it further. And this is what I would suggest that you do, is that you just, you know, at the point where you see this 1/3 exponent and you're like, oh, what do we do here? Turn it into a radical and then see if that looks, you know, good, if there's anything else you can do. So once you turn that back into its cubed root, there wouldn't really be anything that you do here, because the only thing we worry about is if there's cubed roots in the denominator. We don't have a cubed root in the denominator, and we can't cancel that x in the denominator out because the x minus 5 is in parentheses. So that's kind of together. So there's nothing you can really do here. So this would be how you write it. But what I wanted to show you, an alternate route that you could have taken, if I can actually get my pen to write. So the rules of exponents, where you can subtract your exponents when you have dividing, that applies even if you have fractions. So if you didn't take that 1/3, write it as a radical, and then go from there and say, okay, is there anything I need to do? You could have done the 1/3 minus 1 by subtracting the exponents on the x, top minus bottom. So yes, you're going to be subtracting fractions, because 1/3 minus 1, that's equal to 1/3 minus 3/3. So you need to get a common denominator there. And that gives you a negative 2/3. So you are going to end up with this fraction of negative 2/3. And then it's like, okay, well, then what do you do from there? So this route that I'm showing you is the long way to kind of get to where we have, but I'm just showing you that you could get to what I have boxed here if, you know, if you went a different way. That it's not like there's conflicting ways to do a problem and get to the final answer. You can get there if you kind of don't do the easy steps. So the alternate route is you would have those, you would subtract those exponents, which actually I don't need that big natural log anymore. And then you get this new exponent of x to the negative 2/3. And we don't like to have negative exponents like that, so we rewrite it as a fraction. So then you would then have this x minus 5 to the 4th over x to the 2/3. Now, I don't know if you remember this at all from when we were learning about radicals back in week 3. So it's been a long time, and it was glossed over just very slightly when we were talking about radicals and rational exponents. but we don't like to have fraction exponents in the denominator, just like we don't like to have radicals in the denominator. And it's essentially for the same reason. And you get rid of these by multiplying the top and the bottom by something so that they'll cancel out. Kind of get that exponent equal to 1. So what you would do in this case is you would multiply the top and the bottom inside here by x to the 1/3. And you do this because 2/3 plus 1/3 equals 3/3, and that will cancel out that fraction exponent. So this was very, very briefly mentioned in week 3. We really did not hit anything on it. You know, it wasn't something that you really, really need to know. So we just kind of glossed over it. But I'm just showing it if you find yourself, you know, if you just kind of find yourself, you're like, I don't know what to do. So just kind of showing you other things that you can do here. So when you do that, you still have this natural log of x minus 5 to the 4th. You now have an x to the 1/3 power, and kind of notice we're back at where we were. That you ended up with when you're trying to, oh, we can't have fraction exponents in the denominator, so let's try to get rid of that. And you literally end up back with where we were here when we tried to simplify that. So when that happens, let's say you're going through and you're trying to do your algebra, trying to simplify, and you end up back where you started, that is a sign that you are done. Because that's a sign that tells you, oh, I tried to do this and it just took me back to where I was. So that's not really what I want to do. And so that's where you're like, okay, so simplifying or combining these exponents, the 1/3 minus the 1 on the x, is not what you want to do. You want to just rewrite it in its radical form and say you're done. So this is just kind of a side note here, because I know that there are often questions where someone's like, well, how do I know what to do next? Or how do I know when I'm done? Sometimes you don't necessarily know what to do next, and you just give something a try and see if it works. And if it doesn't work, if you get back to where you started with, then that was not the thing to do. And you know, you want to try something else. So that's really what this little alternate sidebar thing is, to show you is not all is lost if you ended off kind of doing something else, because you can always find your way back. But also to kind of demonstrate why I knew that at this point, I just kind of want to write it as a radical, because it's like, once I did so, I'm like, okay, there's not really anything more we can do there. And if we try to do something more, it just takes us back. So are there any questions? And trust me, this example is far more complicated than anything you would see on a quiz. So this is more practice with the rules. But what you would see on a quiz, we don't even have you condense things with fractions. So these are probably what you would see on a quiz, something like this. But the harder ones really, practice what you know and really practice those algebra skills. Okay, so I see no questions.